there. So a couple of days ago, a commenter on one of our videos mentioned asking how it. Give me a moment to pull out that video, and I'll do the introduction again. So I'm recording this because I'm going to cut up this video and turn this into uh, into a video on the channel instead of having the what am I saying here? Instead of it being a stream video, I intend to use footage for this to create a video. So I'm just streaming so that I can do everything in one take. Otherwise, I'll keep re-recording myself. I'll keep redoing the introduction and all this stuff. Right. So previously, our channel had a video like this that talked about how to create different slash visual effects for Hollow Knight. So after watching this video, one of our commenters actually asked how do you add these effects when you hit enemies and the environment, etc. So I thought that this would be something that's worthwhile covering because there are a couple of little details that you have to take note of when doing this. So firstly, right, the two particle effects that I'm going to be showing how you add into your game is the hit splash right here and the slash VFX, which is this. So the slash VFX, right, is this one right here. When you hit something, you will see there is a very exaggerated slash that appears. And then also when you hit a wall, right, you get this little splash right here. So there's one more particle as well. You can apply the same logic to that, which is just the hit splat. But because I haven't created the particle effect, so I'm just gonna show you how you can create this one, how you can add this one right here and this slash effect into your build. And if you have the other particle effects that you have gotten from following this other video, you can use the same logic that I'm sharing with you here to apply these effects to the rest of your game. So if you're curious about how to create these effects, I'm gonna have to refer you to the other video that we have. You will be able to find it in the link in the description below when this video is published. So firstly, let me just talk about how you will go about adding these effects. The first thing you want to do, right, is to make sure that, so for these effects, right, when you put them into your game, because of the way that the game is layered, right, you will actually not see the effects because if you've created the effect yourself, the default layer for these visual effects is actually under the default layer, which in our project, actually, let me just see if I can drag this inspector out so that it can be seen here. So the default layer for particle effects is actually on default, whereas the entirety of our scene is either the midground, background, or foreground. So when you create a particle effect by default, it's not going to show up. Stop this back here. So when you create the particle effect by default, it's just not going to show up, all right? So you have to make sure that you set your sorting layer to a reasonable value, which is I just set it to foreground, right? So that everything is visible. So you want to take special care of this, special note of this, otherwise your particle effect just doesn't show up. So the other thing that you want to do, right, when you create these particle effects is ensure that the prefabs that you have, right, have the correct settings on the inspectors. What do I mean by that? So when you create your prefabs, the position and the rotation might not always be zeroed out. So the thing you want to do is you want to try and you want to zero out your positions. If you can, you zero out the rotations as well. For the slash VFX here, the rotation doesn't really affect anything. So even if I rotate this however I want, it's still going to play the same, and this is just because the effect is agnostic to your orientation. Right, so no matter how you rotate the camera, even in 3D view, you can use these effects in 3D as well if you wish. The rotation just doesn't affect anything, all right? But for the hit splash, right, this one is a little bit trickier because this one is affected by rotation. If I rotate the this thing differently, this actually plays out a little differently because this is directional. It uses a code to determine where the trail is firing. So later on, when we are coding our the effect, right, we have to make sure that this particle effect is facing the correct direction as well. So this is a little bit more interesting to deal with. What I'm gonna do for the heat splash, right, actually is to zero out the rotation here and the position. And then when I move it out, you will see now it actually, the particle effect actually faces the screen like that. Okay, which is actually great for one of the effects that I didn't cover, this one, because this one is just like a splat as well, right? But that's besides the point, because what we actually want to do, right, is to rotate this effect on the y-axis to 90 degrees so that it faces a direction. So I wanted to face the right hand side by default, and I'll explain why later on, because when you do trigonometry, right, the right hand side is 0 degrees, and so the default orientation of anything in a game, 2D game, is usually pointing to the right. So by setting this to 90 degrees, I'm basically setting a default orientation of the hit splash to be facing rightwards. Now that your heat splash is set to 90 here, 0, 0, and 0 on the positions as well. And the slash VFX, this one is less important, but you should still set the position to 0. So now that that's done, right, to play the effect, sorry, one more thing before I move on, right, make sure that both your particle effects have their stop actions set to destroy. And this is because by setting the stop action to destroy, you will get the particle effect to play once. So when I play the game in the editor, right, you will see that the particle effect plays once and it goes away, deletes itself. And you want to have that because these particle effects are going to be, we didn't see the particle effect, right, but it basically played and it destroyed itself. You don't want to have, because we're going to spawn a lot of these particle effects, you don't want them to stay on the scene because they're going to take up RAM in your device, and it's just going to cause memory issues if you keep all of these particle effects on your scene. So once they're done, make sure that they're deleted, and to do that, just set the stop action here to destroy. So the playing of the particle effects itself is pretty straightforward because you just want to find the part in your script that is responsible for, you want to find a part in your script that the particle effect is supposed to play, alright? So we'll start with the slash effect first, which is this. So the slash effect plays whenever you hit an enemy, right? Only when you hit an enemy does the slash effect play. So then you want to go to your player controller script because that is where the attack function is found. And from here, right, you just want to find the area inside the code where the enemy is hit. And that is actually handled by the hit function. So depending on how your project is set up, the thing that you have to do might be slightly different. So because the enemy getting damage is actually done in the hit function, right, what I'm gonna do is just go to the hit function over here, and this is where because enemy gets hit here, right, so I'm just gonna play the effect right here. So to be able to do that, of course, I will have to also add a couple of variables that I can use to assign my VFX prefabs. So I'm just gonna go all the way down under variables here, right under audio. I'm just gonna add a header called VFX. Again, you can choose a name that you find suitable. And this will be demo. This will be particle system, and then heat effect. Prefab is what I'm going to call this. There's also one more, rain heat effect. So I'm creating two variables here under the player character to assign both of these prefabs. And then I'll just have to instantiate the prefab when the correct condition happens. Which is, let me find, where's the player? I can't find the player. So now that I have these, sorry, I should close out my WhatsApp. Now, where was I? Oh yes, so these variables I created, I have to separate these variables instead of using a comma, and that's because I only want one VFX header. So now with the VFX header, with the VFX variables added, you will see, of course, under player there is a VFX header right here, and then there's two variables I can assign. So the more variables you want to play, the more you are going to have to add these variables. If you want to have them be more organized, instead of creating a variable like this, you can create a struct called VFXes, or call them VFXes, and then you can plonk these variables into the struct, and then just create a new VFX variable like that. VFX, and visual effect. So another thing you can do is just this, and then you will get the struct itself inside a drop down. Remember to add system serializable if you want to do this though. Where do we have this? Alright, so you can also add visual effects like these. Depends on how you want to organize this. VFX. I'm gonna use the drop down because this makes things a lot more it's a lot more visual friendly because the player component is so long, right? So having a drop down helps. So once you are done, right, just add in the slash VFX and as well as the hit splash. All right, so with this, the effects are under visual effects over here. So let's go back to the hit function. In the hit function itself, to play the effect, it just requires an instantiate. This, and this will be instantiating visual effects and then hit effect prefab. So where I want to play this is on the enemy itself. So I'm just gonna set the enemy position, and the rotation will be quaternion identity because there's just gonna be no rotation, right? And by doing this, when you hit enemies, you should see the visual effect appear. First time that you hit an enemy, there might be a little bit of a lag because the visual effect needs to be loaded. But let's try this out to ensure that this, whatever I'm showing you, actually works. You see the effect actually it appears. I mean, it's overpowered by some of the other effects that we have, but you can clearly see that it works. And if the visual effect is too small, you can of course scale it up. That's up to you to adjust. The slash VFX is right here, so let me just scale it up a little bit, and then you should see the whole thing look better. Let me just change the if I change the scaling to 2, does that get the effect bigger. There we go. So if the effect is too small, which it appears to be, we can set the scale to 2. Yeah, so the effect appears now. The second effect is a little bit harder to implement because the second effect is what happens when you hit terrain. So for that, we will need to actually do a raycast from. So what we have to do here, right, is firstly we have to, because the hit function only touches enemies, right? So then we will have to go to our player. If you want to play effects on the terrain, right, you're gonna have to go to our player and then change the attackable layer, which controls what colliders can be hit. And we wanna, no, actually, because we have what is ground here, right, you know, we can actually, let's see, we can actually combine the attackable layer and what is ground together like this. So because these two are bit masks, so what actually happens here is if you combine the attackable layer and what is ground, what you are saying essentially is that you want to have the hit detection, right, find ground objects as well as anything that is attackable. So once you've done that, right, the loop over here will actually not always include enemies. So over here, I'm gonna just change the structure of this function here. So instead of doing get component here, a much more appropriate, rather much more easy to use function here would be try get component, because this actually returns true, and then it lets us use the e variable right here as well. So it shortens our code a little bit. And then under the else condition, I can add an else here, and then this else here will be else if objects to hit. So this is basically a loop that runs through everything that we've hit. So then depending on whether it's an enemy or whether it's a wall or whatever, we'll play different effects on the respective components. So this will be out. So this is not. So here we have to check whether the layer is equal to same object layer. How do I check the layer mask? The layer mask, get mask. Okay, here is how you can compare layers. I'm just going to directly do a what is ground here. So this is the way to check whether the layer that we're on belongs to a certain layer mask. So if you want to learn more about this, you have to understand what bit masks are, and for that we have a short. So the link to that short will also be in the description below. So now that we have detected that this is ground, the quick thing to do is just to instantiate the effect first. So this will be terrain hit effect, and then we are going to have to figure out how to rotate the terrain based on which part of the terrain we are hitting. But before we go into doing that, let's just test this out to ensure that the effect actually works when we hit terrain, and we might have to scale up the effect as well if necessary. So it doesn't seem to be hitting terrain very well at the moment. All these items are a little bit of a hassle, right? So the effect isn't playing, so probably something wrong with my logic here. Thank you, it's great to hear. So this is for, I think this video is actually for part 3 or part 4, the part where you do the attacking. So if you're there already, then when this video is up, you can use this video to add some more better visual effects to your project. Let me figure out what's going on here. I'm not sure why this isn't working. Let's put an else if right here. So I'm just testing to make sure that whatever I'm hitting is ground. So if it's ground, then just make things much easier. So it should be detecting when the ground is hit. So right now only the regular stash effect works, but the ground one doesn't exactly work, and not very sure why. Let's figure it out. What is ground on the player is supposed to be something, supposed to be ground, right? So this is not greater than 0, huh? That's why the effect doesn't play. This is false. So here I'm gonna print what is ground first. Then I'm gonna print the layer number itself. What is ground? Is there a way to check? Name the layer. Get mask. But get mask doesn't work here. Okay, this a little bit harder than I thought it was. So we have to use some logic over here. Well, it looks like I've got to explain how this layering thing works, but again, let me just test it out to see whether the code is valid first. And then once the effect starts playing, I can explain what's going on here. Now I've got a null reference exception. And well, that's because we have to find a position to play the effect. So as I've said, it's a little complicated, right? But so for the effect itself, right, we'll have to do a raycast. But maybe before we get into that, let me explain what all these strange symbols are. So firstly, this is a bitwise OR, and remember that we put the attackable layer together with what is ground, and that is because layer masks are basically, you can think of them as they're called bitwise. They're called bitwise. What they call enums, and then how they are saved is they're saved in a bitwise manner. And what this means is that you can think of like these drop downs, right, as being, well, it's just a list of options, and then you can combine a list of options with the single line like this. I don't want to go further than that, because to go further than that would require me to dive into what bitwise math is. So whenever you want to combine options, you use a vertical line, and then whenever you want to um, compare options, so this layer mask here has a couple of options, and we want to see if one particular option here, right, belongs to this layer mask. Okay, so when we use layers, right, the layers are numbered 1 to, they're numbered 1 to 32. They're actually 31 layers, sorry, 0 to 31. And how this thing actually works, right, is that you can think of a layer mask, even the enums as well, as being a set of 32 zeros. Right, set 32 numbers. So then basically what you want to do, right, because the layer mask that we have actually also exists like this. So let's say if you check say option 4 and option 10, then these flags will be turned into ones. So because our layer, let's say, is on ground, right? Ground is layer 3, so layer 3 is 0, 1, 2, 3. So we want the number 1 to be here. So then what we want to do is we want to do 1 left shift game object dot layer, and this gets us the actual number that is that the layer is in. This is actually binary, so in binary 1000 is actually equivalent to, if I'm not wrong, it's 8. So that's because binary comes from 1, 0, 1, 2, 3, and so on, right? So 0 is 0, 1 is 1, 2 is 10, 3 is 11, and then 4 is 100, 5 is 101, 6 is 110. It just goes down. So you can think of them as regular numbers, but then instead of counting by 0, 1, 2, 3, 4, 5, you only have zeros and ones. So then you only count numbers upwards. So this actually is a number, all right? But because we don't want to deal with a number, because this is just a bitwise mask, right? So then you just grab one and you shift it number of layers to get the layer that you need. And what we are doing here is we're converting this number into a bit mask, and then from there we are checking if this bit mask, using the ampersand here, we're checking if this number here, this whatever this layer is in, right, is inside the what is ground mask. Okay, so now that we have the reason why I know that it's found is because if you check the console over here, right, it actually tells you that the error is on line 467, which was here. But then now we have to give a position to our effect, because the E doesn't exist when we get here. So then how I'm going to do it is really simple. I'm just going to do a quick raycast. physics.raycast. This will start. I've got to use physics 2D, right? Why am I using the regular? So I'm going to do a raycast over here. And this raycast will start from the attackable attack point. Zero attack point, attack transform. Dot position. And then it will go either left or right depending on whether the player is facing the left or the right. It could be transformed or local scale x. The vector 2 dot right times. So the effect, I only want it to play either facing left or facing right. So we're just gonna do a raycast. Moves to the right. Distance will be whatever the range of the attack is, which is gotta check the area for that. So we have up attack transform, down side attack transform, which is here. And the area itself is 3.5. Sorry, 4.5. So I'm gonna set a distance here to be 4.5. And then of course the direction, float distance, and lane. So I'm doing a raycast moving towards the right. And what this raycast will do is it will store the result here. So why do we need to get the result of the raycast? Okay, it's because, so over here, if the character is facing right, then the raycast goes right, otherwise it goes left, because this becomes minus something. So I'm just gonna set this to mathf.sign as well, so that it is either +1 or -1. I'm just gonna split this into multiple lines here so the raycast is easier to see. So the raycast starts from the position. It travels. Actually, it shouldn't. It should be starting from the player's position, right? It makes more sense. It's gonna change this to player's position then. So it's gonna raycast rightwards, and then if it touches a wall, then it will register something. So it goes for a distance of 4.5. But perhaps a box cast is better. Box cast all. If I do a box cast all, this will be transformed. Does that work? This is quite a bit more complicated than I thought it would be, because I don't know the player's height as well. So it's a little bit of a problem. Well, actually, I can do a box cast all actually. I think that would be a good idea. So I'll do a box cast. Vector 2, right? This will be the size, right? So if I do that, this will be side that area. Distance will be 0 because it doesn't travel any distance. And then what else do we have? Float angle, size, angle, the direction will just be vector 2 left and right. And then we also need to have this angle, direction, distance. It'll all be in one line. Then layer export. So here I'm doing a box cast that is equivalent to the attack transform. And the reason why I'm doing a box cast, right, is because I want to get the normal of the ground that we're hitting. So for example, this ground over here, right, the normal actually is this line over here. And the normal will allow us to align to determine whether we are hitting like the left or the right side. And then we will have done the effect accordingly. But before we do that, I'm just gonna set this to hit point. And this will be the point where the terrain is hit. I hope this works. Otherwise, I'm gonna have to narrow the box cast a little bit. Yeah, so now the effect actually works. I hope when I'm hitting the ground, it plays when I'm hitting the ground also, unfortunately. So as you can see, the effect plays. It's not exactly in the correct place. So perhaps a raycast would be better. Another thing I can do is, because the box is like this, right? Side attack area. I'll create a new rect. That will be attack transform. So I think actually to keep things simple, right? Because I don't want to overcomplicate things too much. I'm just gonna change this back to a raycast. So what I actually wanted to do, right, was to, with a box cast, what I wanted was actually this. Because the attack area is pretty big. If you do a raycast, right, it's easy to miss. But if I do a box cast, if I do a raycast, it's just gonna be a line. So the line doesn't always hit terrain, you see. So if I jump and I maybe hit a little bit too high, then it doesn't register. But a box cast always registers, and that is what I wanted to do, because the box cast will be like this. But then right now, what the problem is that it's not hitting the so the box cast, right, will cover an area, which means that it's better. But I want it to go like this and get cast out. So that means that I'll have to calculate a start position for the box, and that is I'll have to minus away a new vector 2, because the attack transform is actually in the center right here, and I want to move the attack transform right here. So this means I'll have to minus away the side attack area size x divided by 2. Side attack area is not size, huh? What's this? This is a rectangle, right? Oh, it's a vector 2. So this means that x will be over 2 and the side area y divided by 2. Wow, this is getting out of hand, man. It's quite a bit of math here, surprisingly. Vector 3. And this will be either minus or plus, depending on the direction that we're hitting from. So this will be minus, and f dot sign from localhost, local scale x. This. So what I'm doing is I'm basically moving the line right over here, and then with this, the size, well, I mean the size can just be really small, because the next thing here is a rectangle, right? If I'm doing a box task, then this next variable will be size. Size will just be a very small value, like say vector 2 0.1, and then side area 1. So I just want it very thin, but it's going to be vertically wide. And I think the math, check out for this one. Man, this was I didn't think this would be so difficult to ridiculous. Now it's going the wrong direction. Now it just keeps playing down there. I think what I'm gonna do, right, just to simplify things, right, we can scrap all of this. And instead, what I'm gonna do is to just grab the closest point. Or maybe I can just re-record this whole thing, then I can figure out the code on my own time. I don't want to drag this video for too long. Maybe I should work this out first. Okay, I'm gonna go back and work this out. I have to plan how I wanna organize the code in such a way that makes it easy for me to explain. I'll take my own time to figure it out, and I'll re-record this whole thing again. So